Okay, number 14 is all about this function. So first thing I did was put it into my calculator and I went zoom 6. And this window is not great. It's a cubic, so I know that it's falling to the left and rising to the right. But I'm not seeing a complete picture here because I can't see the y-intercept, which I know is at negative 15. So I think I'm going to go and adjust my window. I don't think I need as many x's, just because it's growing so fast, and I need more negative y's. And I'm just going to make my y scale 0, just because otherwise the marks will be too close on the y-axis. So let's see. I think even more negative y's might be good. So maybe let's go down to negative 40. Let's take a look. Oh yeah, that looks better. Okay, good. So the end behavior, okay, as x approaches negative infinity, my function, y, approaches negative infinity. It goes down to the left. And as x approaches positive infinity, my function also approaches positive infinity because it goes up to the right. Down to the left, up to the right. B. They ask me the number of positive real solutions. The number of positive real roots. There's one positive root. C. What's the list of possible rational solutions? Possible rational zeros, P or Z's, are factors of negative 15, so plus or minus 1, 3, 5, and 15, divided by factors of the lead coefficient, which is 1. So there are only 8 of them, positive or negative 1, positive or negative 3, positive or negative 5, positive or negative 15. No. D asks for what are the rational solutions. So because I can see it on my graph, I can just ask for the 0. So I need to go left. The 0 is somewhere between there and here. So it's at 3. X equals 3. And then they want all the solutions. That's the one where you have to divide in the one solution that you get and see what the remainder is. So divide 3 into 1x cubed negative 7x squared, 17x's minus 15. I don't need any placeholders because nothing is missing. Bring the 1 down, then just multiply and add. 1 times 3 is 3. Negative 7 plus 3 is negative 4. Negative 4 times 3, negative 12. 17 minus 12, 5. 5 times 3, 15. My remainder is 0. Always put a smiley face on because that means that that's true. So this is 1x squared minus 4x plus 5. So that means my function could be written as x minus 3 times this. Now, x squared minus 4x plus 5 is not factorable. The roots are not real. So the zeros for here is where x minus 3 equals 0. That happens where x is 3. The zeros for this, x squared minus 4x plus 5 equals 0. Not factorable, so I'm going to use the quadratic formula. X equals negative b, so negative negative 4, which is positive 4, plus or minus the square root of b squared, so negative 4 squared, which is 16, minus 4 times 1 times 5, minus 20, all over 2a, which is 2. So it's 4 plus or minus the square root of negative 4 divided by 2, which is 4 plus or minus 2i, because the square root of 4 is 2, the square root of negative 1 is I, divided by 2. So my zeros are 2 plus or minus 1i, because I have to divide 4 by 2 and 2i divided by 2. So these are the other two zeros. My zeros are 2 plus I, 2 minus I, and 3. 3 zeros, because it's a third degree function.